Hello, my name is Jordana Cipriano. This is my Sleep in the Brain video project number 2 for psychology F111X. Apologies for the background, I'll explain at the end. But without further ado, because this video is supposed to be 10 minutes and it probably won't be, let's jump right into it. So, table of contents. First, I'm going to talk about neurotransmitters, what they are, and how they impact this sleep and the involvement of such in the sleep process. Hormones, pretty much the same thing. Thirdly, I'm going to go over some studies from Dr. Matt Walker's TED Talk, or rather one in particular. Fourth and fifth, I'm going to talk about, again, the TED Talk, but fourth, I'm going to focus on the consequences of sleep deprivation. And for the fifth topic, I'm going to be talking about some strategies to prevent said sleep deprivation. And six is just going to include some closing comments or reflections. So let's talk about neurotransmitters. So, what are neurotransmitters? Well, according to, and I know I wrote it out, but I'm just going to refer to it for the sake of the video as the textbook. Neurotransmitters are the chemical signals that travel between neurons, allowing them to communicate. There are many different types of neurotransmitters, each with a specific role. For example, serotonin influences sleep, appetite, and mood. Now, if you look at this little graphic, you'll see the neurotransmitter is quite tiny, but it's quite involved within neurotransmission. So, a very important thing to note. So, sleep deprivation and neurotransmitters. I'm going to go over a few neurotransmitters in particular. First, I'm going to start with adenosine, or at least I believe that's how it's pronounced. I'll probably mispronounce quite a few things in this video, so it's a good thing I have a PowerPoint. So basic functions. So it builds up during wakefulness and acts as an inhibitory neuromodulator, reducing arousal neuron firing. Its role in sleep and wake is that it promotes sleep pressure and helps trigger NREM sleep. The brain regions and circuits involved in such are going to be the basal forebrain and the cortex. So next we have GABA, or gamma aminobutyric acid. Again, hoping I pronounced that right. Basic function is the brain's main inhibitory neurotransmitter that decreases neural activity. Its role in sleep and wake is that it suppresses arousal systems to initiate and maintain sleep. The brain regions and circuits involved in such are the ventrolateral preoptic areas, the VLPO, and the hypothalamus. Thirdly, we have, and this one's really tricky for me to say, so bear with me, acetylcholine, acetylcholine, I believe. I always want to say chlorine, but there's no R, or ACH for short. Some basic functions are it's an excitatory neurotransmitter that is vital for attention and arousal. Its role in sleep and wake is that it encourages wakefulness and REM sleep, and is low during NREM sleep, or rather deep NREM sleep, I should say. The brain and circuits involved in such are the basal forebrain, pons, and the midbrain. Serotonin, everyone's favorite, also known as 5-HT. The basic functions of such are it is a modulatory transmitter affecting mood, sleep, and appetite. The role in sleep and wake is that it initiates NREM sleep and suppresses REM sleep at high levels. The brain region and circuits involved in such are the raphe nuclei. Norepinephrine or noradrenaline, yet another neurotransmitter on this list. Basic functions are excitatory neurotransmitters involved in sympathetic nervous system and arousal. The role in sleep and wake is that it's high in wakefulness and it decreases in NREM, and it's nearly inactive or silent during REM. The brain region and circuits involved in such are the locus coeruleus, the brainstem, just fancy word for it. Dopamine, another favorite. Basic functions are it modulates reward, motivation, and movement. Its role in sleep and wake is that it boosts alertness. High dopamine usually causes insomnia, while low dopamine generally leads to sleepiness. Insomnia meaning the difficulty to sleep or the inability to sleep. Brain regions and circuits involved in such are the ventral tegmental area and the substantia nigra. Histamine, or histamine, whichever. Basic functions are an excitatory Yeah, modulator that encourages wakefulness.
Yeah.
Its role in sleep and wake is that it's high wake levels, low sleep levels, and antihistamines cause drowsiness. The brain region and circuits are the mammillary nucleus, or the TMN, if you want to not stumble over your words like myself. Orexin or hypocretin. I always want to say creatine, but that is not the case. Some basic functions or neuropeptide that maintains wakefulness consistent with the described hypothalamic role. The role in sleep and wake is that it prevents abrupt REM transitions. Losing this can lead to narcolepsy, the exact opposite of insomnia, where you um, can typically fall asleep when you don't need to. Brain regions and circuits involved are the lateral hypothalamus. Last but not least, melatonin. This one's kind of obvious. It's secreted by the pineal gland. It's technically not a neurotransmitter, but it influences neural circuits that regulate circadian rhythm. And how can you talk about sleep without talking about melatonin? So, the role in sleep and wake is that it signals night and helps synchronize sleep patterns, our circadian rhythm. And the brain regions and circuits involved are the pineal gland and the SCN. All right, that's enough of neurotransmitters. Let's talk about hormones. So, what are hormones? Well, according to the textbook, hormones are a chemical messenger released by endocrine glands that travel through the blood to influence the nervous system, regulating behaviors such as aggression, mating, and parenting. Hormones are arguably similar to neurotransmitters, but they can operate over a greater distance and over a much greater temporal range than neurotransmitters. Take a look at the well, if you can see it, it might be a bit tiny on your screen. Let me There we go. Um, as you can see, there's quite more parts of the body involved versus neurotransmitters, which can typically, as far as I understand from the reading this week, mainly consist in the brain. So let's talk about sleep and hormones. So first and foremost, we got cortisol, which is a corticoid. So, some behavioral and psychological roles of such are stress, arousal, metabolism, and behavioral regulation. Some known slash inferred roles in sleep include, but are not limited to, high cortisol levels are usually associated with wakefulness and alertness. Lower levels help promote deeper sleep. Cortisol, of course, is related directly to stress. So, if you're very stressed, you're probably not going to sleep quite so easily. And again, in the notes, cortisol follows a daily pattern, peaking in the morning and decreasing at night. Elevated evening cortisol or stress can hinder sleep onset. Testosterone, a steroid sex hormone, its role is to regulate reproduction, sexual behavior, and secondary sex characteristics. Its known and inferred roles in sleep are or rather, specifically for women, I guess. Fluctuations in these hormones, especially in women, as I said, can affect sleep patterns. And some notes in women, progesterone has a sedative or sleep promoting effect. Menopausal hormone changes can often disrupt sleep. There wasn't too much information on how testosterone really affects sleep in men, but I suppose since we are more estrogen based, having a high testosterone level may disrupt that hormone balance. Prolactin, peptide hormone, one of many on this list. So the behavioral roles of such are involved in lactation and parenting behaviors. Some known and inferred roles in sleep are elevated. Prolactin levels are sometimes linked to increased sleepiness. Some notes on such after childbirth, prolactin peaks might affect a mother's sleep patterns. Wasn't too much information on that one, but I chose to incorporate it anyways. Oxytocin slash vasopressin, another peptide hormone. The behavior of such is social bonding and parental behavior. Some known or inferred roles in sleep are potential modulators of sleep patterns. Some notes. Some studies suggest that oxytocin can affect REM and slow wave sleep. But there were a lot of details kind of left out in the book, so I'm not quite sure what else to add to that. Leptin, a peptide, but this one specifically is from fat cells. It regulates hunger and feelings of fullness. Some known and inferred roles in sleep are that it indirectly influences sleep via energy balance. And in my notes, of course, I keep that, or I note that, note. Sleep loss can reduce leptin, which can result in increased appetite and disrupt metabolic signaling. And now we're on to the studies from Dr. Matt Walker's TED Talk. So, a quote I chose to incorporate in this slide that relates to the study that I chose is as follows. What you find is a quite significant 40% deficit in the ability of the brain to make new memories without sleep, directly from the mouth of Dr. Matt Walker. So, in the TED Talk, I chose a study because we were to choose one, sleep deprivation and memory formation. So, one of the studies that Dr. Matt Walker mentioned in his TED Talk was a controlled experiment on sleep deprivation and memory formation, also known as the All Nighters Study. In this study, participants were divided into two groups. One group slept the full recommended 8 hours, known as the sleep group, very creative, and while the other stayed awake all night under the supervision of the sleep deprived group. The next day, participants from both groups underwent an MRI while trying to learn new information, a brain scan, in other words, allowing researchers to observe the brain activity related to memory formation, I believe, within the hippocampus specifically. So, the findings of such are the sleep deprived group experienced a significant 40% decrease in their ability to form new memories compared to those who slept normally. Brain imaging showed that activity in the hippocampus, the part of the brain responsible for receiving and storing new information, was nearly completely shut down in those who hadn't slept. In other words, the memory part of the brain had completely stopped storing information. These results showed why sleep is important both before and after learning. So, in other words, kind of what I gather from this is that in order to preserve energy, as the brain runs out of such without sleep, it kind of shuts down parts that it deems not quite as necessary, which, I mean, nowadays memory, of course, is very necessary and learning is too, but I suppose in a survival scenario, maybe less so. So the assignment asked for my opinions or reflections on this study and information that I learned, but to be honest with you, there's not much I can say that wasn't already included in the findings or that I didn't kind of inject in commentary already. So, I mean, I believe it's important to mention that sleep deprivation can lead to temporary and in severe cases permanent brain damage. Um, excuse me. Honestly, I can't say this will stop me from staying up all night to do my homework and study, especially since I work a full-time job to pay for this education. So it's kind of eye-opening to see how shriveled my brain will be in about 4 years, give or take. Consequences, according to Dr. Matt Walker. So, some consequences of sleep deprivation. There were several consequences of chronic sleep loss that Dr. Walker discussed in his TED Talk. However, this isn't necessarily one thought that was the most severe because they're all pretty severe, but the one that I chose for the sake of the assignment was the link between sleep deprivation and its impact on the amygdala. The amygdala, furthermore, and is very close to the hippocampus, so ironic, um, is the brain's emotion processing center becoming hyper reactive and sleep deprived, while the prefrontal cortex, which normally controls emotion, loses its ability to regulate. This imbalance, which is such an awesome combination, of course, sarcasm included, leads to mood swings, anxiety, and in extreme cases, hallucinations and psychotic like symptoms. And then just as a note, I did do further research for this because I know that in the original TED Talk, he does talk a lot about like the immune system and its negative impacts on such. So if you wanted one specifically from that TED Talk, but I did a little digging and I found another lecture he did for the University of California where he talks more about like psychosis, and I thought that was really interesting. So I wanted to include that because I didn't figure anyone else would have. Some strategies. Ignore that you can add subtitle here if you need it. Apologies, I left that in the template. I will delete that before uploading the PowerPoint. I'm going to skip over that. So, some strategies. The assignment asks for strategies specifically for college students to improve sleep. And I'm going to be frank with you, I don't think there are any that are going to work, but we can always try, right? So, the first of which is regulation, right? Regulatory. Going to bed and waking up at the same time every day can really benefit getting a good night's sleep. Temperature control, keeping the bedroom cool around 65 degrees Fahrenheit or 18 degrees Celsius can also improve sleep. But regarding college students, the most effective strategy seems to be maintaining regularity. Students, like myself, often managing consistent schedules, late night studying, social events, part time jobs, so on and so forth. Um, all of these can disrupt their body's circadian rhythm. So, in closing, the hippocampus, amygdala, prefrontal cortex, and many other parts of the brain are disrupted by sleep deprivation. Your brain needs sleep, bottom line. The only problem with such is that us as individuals, our current society, we're not really sleep oriented. I mean, for example, college, right? The assumption is that if you're a full time student, you have all day, all night. Well, less so all night because you want to sleep, but you have all day to complete your work. But it kind of also negates the idea that a lot of us, unfortunately, don't have time during the day. So we stay up late to do our work, such as myself. So, like, in those kind of cases, or in the case where a student is taking like very challenging courses where they have to stay up very late to study for such, I think that it's very difficult to simply say just go to sleep because at the end of the day, as lenient as our professors are and as cool as they are as well, you can only get away with saying that I didn't have enough time for so long. The world is not accommodating to sleep. So to really kind of come up with like a one size fits all solution to avoiding sleep deprivation, I'm not really convinced that there is one, but it was really interesting to go over some of the effects and potential preventions within this lesson. So, that being said, I'm Jordana Cipriano, coming in from my bathroom floor. I live in a very tiny apartment with a roommate. I'm not sure if I mentioned that in this take because one of my takes got corrupted, so I had to redo this whole video. But yeah, this is the only place I could record today. So, in the future, I'll probably not be on the bathroom floor. Maybe, but apologies, I'll edit out any annoying noises or maybe attempt to fix my mispronunciations, but yeah, that being said, thank you for watching.